Yay, let's do the U substitution. We introduced this a little bit yesterday. Now today is a real time for us to do this skill. I will start to call student now. Kevin, let's do this question. This example. Look at this. This guy is x squared plus 1, but here is to the power of 5. And this is 2x. So you want to make u equals to who? Look at this. If you make this whole thing as u, possibly you will be able to solve it. So let's call u equals to x squared plus 1. So far, so good?
Yeah.
Then du is going to be du over dx will becomes to what? This is like y. dy over dx is? This guy derivative is who?
Okay. 2x.
2x. So that means du equals to 2x times dx. So far, so good?
Yes.
Now, let's replace everything to u. This will become to who?
U to the fifth power.
U to the power of 5. Who is this guy?
That's du.
du. Then this will become?
Du to the sixth power.
So you can do u to the power of 6, correct?
Yes.
But u to the power of 6 derivative is 6 times u to the power of 5. So you want to make this equal, you have to divide it by a 1 over 6 to make it equal. Does this make sense now?
Yes.
So you have this u, and you will replace this back to be x. That's it. Does this make sense?
Yes.
This is interesting, right? The USub is pretty cool. Next one, Helen.
Yeah.
Let's try this. You want u to be who?
2x. Q plus 5.
So you make u equals to 2x cubed plus 5. Okay? And then du over dx will be
6x squared.
6x squared. So du is equals to 6x squared times dx. So far, so good?
Yes.
And then you will divide it by 6. So 1 over 6 du equals to x squared dx. That's fine, right? And then, did you notice that this become? This is who?
U to the 4th.
U to the power of 4. And this guy, x squared dx is 1/6 du. Correct? So we have 1 over 6 in front, and the inside is u to the power of 4, and this thing is du here. So let's do this one more time. This become?
The derivative.
This will become 12.
4 over 6.
Hold on. U to the power of 4. You want to make this the antiderivative. You will do 4 plus 1, which is 5, correct?
Yeah.
So this guy becomes to u to the power of 5. Yeah? And then you have the 5, so you have 2 times 1 over 5 in front. And you copy down this 1 over 6. Did you see? This guy, derivative is 5 times u to the power of 4. And then times 1 over 5. And then copy down the 1 over 6. 1 over 5 canceled. That's why this equals to this. Yeah, this guy derivative equals this. And then you will plus a constant c. So this is 1 over 30 u to the power 5 plus c. But you cannot leave the u there. You have to change it back, which is 2x cubed plus 5. And don't forget to put this constant number, okay?
Okay.
And then you can say, oh, this is here, okay? That's it. Does this make sense to you now?
Yeah.
Next one. Maggie, let's try this example. You want u to be who?
X squared plus 3.
Good, that's a good try. So you make u as x squared plus 3. Then your du will be du over dx, which is,
2x.
and du is 2x dx. Okay?
Yeah.
So 1/2, you divide by 2 for both sides. So x dx. This is x, this is dx. This guy is this guy.
Yeah.
That is the du. So this part is du. And who will be this? Square root of u, correct?
Yeah.
So you have the square root of u. When we have those radical stuff, we will change this guy to be the fraction format. Square root of u.
Don't you need to multiply by 1/2?
Oh yeah,
'Cause-
good catching. Yes, I forgot. Good catching. So we have a 1/2 over here. Yeah, we have 1/2 over here. And then u to the power of 1/2 is square root u, right?
Yeah.
Okay, and then how do we change this one? Look, when we do the derivative, x to the power n, when we do this prime, it's n put in front times x to the power n minus 1. But when we do x to the power n and then dx, we want to do this opposite direction. What we do? We will not minus 1, we will plus 1. So this will be n plus 1. But in the front, you will divide it by this. That's what's going on. So this guy, derivative is n plus 1 times x to the power n, divided by n plus 1. So that's canceled. So that means this equals this. So whenever we see something like this, we are going to plus this guy by 1. 1/2 plus 1 will be?
3/2.
So 3/2. But we will times the 3/2 reciprocal. So we put here to be?
2/3.
2/3. That's what's going on. So far, so good?
Yeah.
And then this 2 and this 2 canceled. This becomes 1/3 times u to the power of 3 over 2 plus c. We have to convert it to x only. So we will copy down whoever is u. That's it. Okay? Does this make sense?
Yes.
Okay. Next one. Kyle.
Hi. Sorry I'm
Let's
late.
do this. Yeah, let's do this one here.
Okay.
You want your u to be who?
X. X, right?
Hold on. If you make u as x squared, and then your du is 2x times dx, correct?
Yeah.
So you can say this becomes to 3u plus 4, right?
And then the top will just be 1/2 u.
So
Right.
x times dx is 1/2 of du, okay?
Okay.
And then you will say this is 1/2. And this is a fraction 1 over square root of 3u plus 4, correct?
In du, right?
du. Mhm.
Yeah.
And then you have say this is 1/2, and then you do 3u plus 4 to the power of negative 1 over 2, and then du. And what you want to do next?
We do chain rule. Well, kind of the opposite.
Yeah, sure. So what do you want to do?
Do we put 1/2 in front?
Hold on. So you might think this guy, you can say, you can treat this thing, you can make something like this. You can say that d of 3u plus 4. Yeah, this is another variable like a v. So d of this guy is going to d of this guy. This is who? 3 take out 3 times du. 4 is a constant, and d of this 4 is 0. This is constant, so there's nothing. So 3 times du. Do you see this? Does this make sense to you?
So is it d over du time?
So here, if you don't understand this way, that's fine. I'm going to make this thing called v. You can call v equals to 3u plus 4. Yes.
Sure.
And then your dv over du is 3, correct?
Yeah.
So the dv equals to 3 times du, correct?
Yes.
Yes. And then du is 1/3 of dv, correct?
And then we just put in.
So yes, so this is 1/2. And then 3u plus 4, which is v to the power of negative 1/2. And du is 1/3 of dv, so you times 1/3. And then you do a dv, correct?
Okay, yeah.
And then you can make this as 1/6, right?
Wait, so
Yes.
the stuff in the integral you can also put outside.
Yeah, you can do this outside.
Constant,
And
yeah.
then basically you are doing this. V to the power negative 1/2. You are doing the antiderivative, so you should plus 1. Negative 1/2 plus 1 will be positive 1/2. 1/2 the reciprocal is 2.
2, yeah.
See? This
Yeah.
is 1/3 v to the power 1/2 plus c. So far so good?
Yes. Then
And then v is who?
3u plus 4. Which is.
V is 3u plus 4. Correct?
Yeah.
And 3u, u is x squared. So this is 1/3 3x squared plus 4 to the power 1/2, then plus c. Correct?
Yes. And we're finished.
Now, yeah, and I don't want you to use this way. The way doing this is too long. Let's use a simple way. If you have the guys here on the denominator, you are going to make whoever is inside this whole thing as u. You will save your time. Go, let's do it. If you make this whole thing as u, you will do this guy, du equals to who? Go, come, do this.
6x plus, no, just 6x.
6x dx, correct?
Yeah.
And then your x dx equals to 1/6 of du, correct?
Mm-hmm.
So that thing, this antiderivative, x dx is 1/6. And then du, correct?
Yeah, and
And
Oh.
that guy is u square root of u. You got it? This is u. Yes.
X just came out. Oh.
Yeah. And this is 1 over 6 u to the power negative 1/2 du. Okay?
Okay.
And then go. You can do this.
1/6 times -2, or no, just 2.
So times 2 times
Yeah.
u to the power negative 1/2 plus 1, which is positive 1/2. Yeah? This guy reciprocal is 2, right?
Yeah.
Then plus c, correct? Yes.
Oh, yeah.
So this is 1/3. U is who? U is 3x squared plus 4. Yeah?
Mm-hmm.
That's it. Did you see? We can save the time by using this. But here we have to do 2 individual steps. But here in one way, just one variables, we are able to solve this whole thing. Does this make sense?
Yeah, but when do you know when to just do that?
You don't know unless you practiced at least 100 questions.
I
You
got
don't do it. Yeah, those things, this thing is easy. Everybody can tell. Sometimes it's going to be more complicated. Right now, we haven't seen the very hard one. But you look, even you finish 10 years of medical school, but for the first year, you still cannot treat patients very well because you haven't seen too many different cases. Your experience matters here. Unless you practice a lot, before that, you don't really know. You try this way, doesn't work for here. You have to do one more step. The next step, next time you see this, you say, oh, I don't want x squared as u. I want to make this whole thing as u. You see this example, next time you do it, you can tell the right way. Okay?
Cool, yeah.
Yeah, that's why we learn in summer. And before school start, you redo this. And when school start, your teacher start to teach this, and you say, oh, this becomes so easy for me now because you practice a lot. Okay?
Mm-hmm.
Next one. This guy here. Felix. Felix, let's see how do we do this one.
Would cosine turn into sine x?
We can make u as 3x. Yeah?
Yeah.
Correct? U equals to 3x. Okay?
Yeah.
And then cosine u, right? Yes. 3x becomes to u, right? So you have cosine u, correct?
Yeah.
And then du over dx is who?
3.
Du over dx is 3. So du is 3 times dx, correct?
Yeah.
So dx is 1/3 of du, correct?
Yeah.
So you have 1/3, you pull this outside, and then you put du right here. Come on, you can do this. Who is this guy?
1/3 sine sine u plus c.
So you have 1/3 sine u. Very good, because sine u derivative is u. Yeah, sine u derivative is cosine u. And then you plus a c. But you cannot leave this. You have to put the x back. Okay?
Yeah.
Makes sense? Interesting, right?
Yeah.
Any other question here? Everybody are doing fine, right? Next one. Kevin, I give you a challenge question here.
Okay.
First, I want you to take a look at this. You have sine cube, you have cosine. And you want to use something called USub.
Yeah. Let's sub sine cubed x for u. Can we do
So you can say u equals to sine x. That sounds good.
that? Okay.
Then du over dx will be
Cosine x.
cosine x. That is saying du equals to cosine x dx. Correct?
Yes.
And then
So
This
it would be
is-
du.
this is du. This part is
U cubed.
good. Pretty good. So this is u cubed. This is du.
Okay.
You can do the last step correct. Keep going.
Okay. So
This is 3. So you will add 3 to be how much? 3 plus
wait,
1 will
we're
be?
not gonna put sine x back in?
Not yet. You want to do this antiderivative and then you put back
Okay,
x.
so 3 u
No. 3 plus 1 is who? You want to add this guy to be the antiderivative. You do this guy, derivative is 3u squared, but you do antiderivative, so you do 3 plus 1, which is?
4.
Yes. So u to the power 4. And then you
Okay.
do full reciprocal, which is 1 over 4.
Yeah.
And then you plus a constant c.
Now we can put sine x back in.
Yes.
So 1/4 sine x
Sine-
sine to the
Fourth
4th
power,
power x plus c.
Yeah, because sine x parenthesis to the power 4 means you do the 4 in this middle position.
Okay.
Okay, that's it. Next one. Helen, try this one, please.
You could make u sine of 5x.
Good. And then
So
du over dx.
d over dx is cosine 5x
This is cosine phi x times. This is phi.
right, times
Phi.
yeah,
And then du over dx equals to who? Oh, sorry, du equals to
cosine 5x times 5 times dx.
yes. So you can put 1 over 5 in front, right?
Mhm.
So far, so good.
Yes.
And then
u cubed times 150u.
u cubed times 1 over 5 du, right?
Mhm.
So far, so good.
Yes, so then that turns into 1/4
Times 1/4 times
times u to the 4th
good plus c equals to
1/20 times sine to the 4th of 5x plus c.
mhm. So this is 1 over 20 u to the power of 4 plus c, which is 1 over 20 times sine 4th here, 5x plus c. Correct?
Mhm.
That makes sense, right?
Mhm.
So far, so good. This, okay? Next one, Any questions so far, all the student? If you say, can we go through one question? Can you walk through with me one more time? Ask me. All these questions we have been through. Do you need help? Let me know. Now we will see these complicated ones. This guy here. Who want to do this?
I'll do it.
Okay, you want your u to be who?
Cosine x squared.
That's a good try. So you make your u as cosine x squared. Okay?
Yeah.
And then your du is du over dx will be
Negative sine x squared times 2x.
good. Negative sine x squared. Cosine derivative is negative sine. And then you do the chain rule. X squared derivative is 2x. Okay? So
Yeah.
that means du equals to negative sine x squared times 2 times x times dx. Okay? So negative 1/2 times du is equals to sine x squared times x times dx. Okay?
Yeah.
So that means this guy, and this guy is
They are.
basically this
Yeah.
guy. And also, so you have a negative 1/2. And this thing will be replaced by du. And then this guy is who?
That's u to the fourth power.
U to the fourth power. U to the fourth power. And then keep going.
Let's use the inverse of chain rule. So negative 1/2 times 1/5 u.
Good. Yes, you got it. 5. Yes.
Yeah.
And then this become
Negative 1/10. And we can put u back as cosine.
So you have negative 1/10 times this is cosine, and then you do the fifth in the middle. You copy down the x squared here. Yay! Say, I did it.
Woo! Celebration.
Yeah, you made it. Good job. Very good. Next one. You will see something new. This is called solving the differential equation. This is solving the differential equation. So you have the dy over dx as this. And then you want to solve this differential equation. You might say, oh, I feel this is something new. I never see this before. You can times the dx. So for this one, you do this first. You do the dx, you put the other side. So you do this guy here. You times the dx to the other side. And then you will do this integral. Or you can call this antiderivative. And then you will say, oh, this guy is doing the derivative. This guy is doing the integral. So these two cancel to each other. That means you have the y equals to that guy. Okay? Basically, this means y equals to this thing. And you can, this part is easy to get. But this part, we have to manipulate with the u substitution. And here, look. I'm going to hide my answer here. So I want you to use the u substitution. I give you the hint here. This integral of phi x dx, this is phi times 1/2 x squared, yeah, plus c. So this part is easy. I want you guys to do this part by yourself. by using a u equals to 1 plus x cubed, so that you can figure out how much is this. Go ahead, do this integral. Then you will be able to have your y expression. Go ahead, do this one. When you finish, please send me a picture of your work. Hey, we have several students already finished. Felix, double check your phi x dx. You are not doing phi x derivative, you are doing the antiderivative. You have these complicated parts correct, but you have the simple part wrong, Felix. Fix that. This is phi over 2 times x squared. Right, Felix? Hey, Helen. Helen, unmute yourself.
I don't know what I did either.
You make u equals this whole thing, yeah? U as this 1 plus x cubed.
Oh, it was X.
Yeah, this is x cubed. Did you see?
Mm-hmm.
Now you can do it, right? du is going to be 3x squared dx. So that means the x squared dx can be replaced. You will not have any x squared dx anymore here. You will have the parts of u only.
Mm-hmm.
Yeah. Okay. That's it. But this question is very interesting. I will show you guys this. Look, this is called differential equation. And this is also called the slope field. So I'm going to show you how do we do this in the TI Inspire. And then we will see the general solution. We will see the specific solution. Okay, I will show this in the end of at the end of the class. And now I'm going to talk about more USub here. So let's see here, this guy here. For this part of question, not only we will solve the antiderivative, but also we will plug in the lower bound and upper bound. So let's see the number 1. Kyle, let's do this guy here. You want your u to be who?
X squared?
Eh.
Okay.
See?
Or the whole thing. Oh, x squared plus 1.
Yes. So we make u as x squared plus 1. Then du, hold on, du will be
2x dx.
2x times dx. So 1/2 of du equals to x times dx. Correct?
Yeah.
And then the x times dx is 1/2 of du. So you have 1/2. X dx is du. Who is this?
U to the third.
U to the power 3. So far, so good?
Yeah.
So when x equals to 0, u will be
Will it be 1?
1. When x equals to 1, u will be
2.
2. So you have 1 here. You have 2 here. So far, so good?
Yeah.
And then we are going to make this guy. Don't worry about this first. Let's do this antiderivative. U to the power 3 antiderivative. U will plus 3 by 1, which is
4. So 1/4 times u to the 4th.
so you have 1/2 outside.
Yeah.
Times 1/4. Times u to the power 4. And then you have 1 here, you have 2 here. So far, so good?
Okay.
And then you have 1/8. Parentheses, you have 2 to the power 4 minus 1 to the power 4. Who is 2 to the power 4?
16 minus 1, so 15.
That's it. This is what's going on. Makes sense now, right?
Ah, okay.
That's what's going on. And then number 2. Kevin,
Yes.
you want your u to be who?
X.
Hold on.
No, wait.
You see?
Yeah, x cubed plus 1.
Yes, you want to look for the guy under the radical. So you make your u to be x cubed plus 1.
Are we missing someone today?
Huh? Yes,
Are we missing?
a girl is missing. Sisha missed today's class. So u is x cubed plus 1. So du is who?
Oh, I don't know for this one.
Du over dx will be who? U is like your y. Dy over dx will be 3x squared, right? Yes,
I
Kevin?
don't understand.
Why you don't understand? This is the power rule. This is y equals this. So your dy over dx is 3x squared.
Oh wait, I was looking at the previous question. I was looking at the
No, look at here. You got it?
Yes.
So du equals to 3x squared dx. So far, so good?
Yes.
So that means x squared dx is going to be 1/3 of du. Okay? Then look at here. X squared dx. So you pull this 1/3 outside. And then this guy become
Root of u.
square root of u, right?
Yeah, we can
This
write
is
u
u.
to the power
Yeah.
of 1/2.
And this guy is the 1/3 du, correct?
Yes.
That's it. Next, you notice that this guy can be rewrite as
U to the power of 1/2.
1/2. And then go ahead, do the antiderivative.
So 1/2 U negative 1/2.
No, 1/2 plus 1 will be
Oh yeah, plus 3/2.
3/2. 3/2 reciprocal is 3/2 reciprocal is
2/3.
2/3. And then plus c, but you will do the antiderivative. Okay?
Mm-hmm.
Now, when x equals to 0, u will be
0.
when x is 0, u will
Oh
be
no, 1.
1.
Yes.
When x is 1, u will be
2.
2. So this is from 1 to 2. Correct?
Yes.
So this is 2/9. And then this is a 2 to the power of 3/2 minus 1 to the power of 3/2, which is 1. Okay?
Okay.
That's what's going on. Okay? The more you do it, the better you can do those kind of questions. Yeah? If in your school this is the first time, for example, your teacher just teach this very quickly, yeah, showing you the first simple examples, and then during the test give you something crazy like this. How can you prepare for tomorrow's test? It's too late. You learn it in the summer. Before school start, you redo this. When school teach this, you can do most of the thing perfect. And before the test, you re-practice. You have prepared 4 times. That's why you can be perfect. Number 3, Kyle.
Okay. Didn't we just do one 2 questions ago?
Similar. Now you notice that it's all similar.
All right. Okay, u I guess is 2x² plus 2.
So you want u as x squared plus 1. Now you can do this. You can get your u perfect.
Yeah.
Yeah. Go. Keep going.
The sign's right there. Okay.
So du
equals 2x dx.
good. Now when you rewrite this in this format, you feel it very comfortable, right?
Yeah. Okay.
And then
So 1/2 dx is x dx, right?
so this 1/2 du is x dx. So you have 1/2 in the front, right?
Yeah.
And then you have this du here, okay? And you will have x dx, which is du. And who is this?
U cube.
U cube. And then when x equals to -2, u is
It's 6.
when x equals to -1, u is
Stress. 3.
3. Make sure put this number at the correct location. Don't say 3, 6, always make this larger upper. No, not really. When x is -2, u is 6, so you honor their position. Okay?
Yeah.
And then this is 1/2, this is 3, this is 6, this is u to the power -3. This is a time for you to do the antiderivative.
Sure. So 1/2 times.
You plus this guy by 1 first. So this becomes u to the power of who?
-2.
Yes. And then you do -2 reciprocal, which is
(1/2).
-1/2.
Oh,
correct?
yeah.
And then you do this long bar, and you put 3 here, 6 here. So this is -1/4 u to the power -2. So you use always this guy, higher guy, plug in, minus the lower guy. Okay?
Yeah.
So this is -1/4. And then this is 1/9 minus 1/36. Yes.
So the end is 3/6.
So this is -1/4. You do the common denominator, which is 36. Then you do 4 minus 1, which is 3. Correct?
Yeah.
And then you cancel 1, you cancel 12. So this give you a -1/48. You got it?
Yeah.
That's what's going on, okay? This is number 3. Now, number 4. Maggie, I want you to try this question because this is those kind of piecewise. So you need to split. You need to split this into 2 parts.
Okay. Do you still do the u? U is equal to
Not really. We can just find the from here to here. Where is the point that this guy switched the sign? When this guy equals to 0, 2x minus 1 equals to 0, right?
yeah.
So x equals to 1/2. Correct?
Yeah.
So that means before x equals to 1/2. So it's from -1 to 1/2. Okay? From -1 to positive 1/2. This part will be less than 0.
Negative.
So it's this guy with a negative. So you
Yeah.
have -2x plus 1 dx. So far, so good?
Yeah.
And then plus, you will do 1/2 and then to 4.
4.
And then you do 2x minus 1 dx. So far, so good?
Mhm.
And then, who is this guy antiderivative?
Negative 2 times.
This is
Wait,
negative x
no.
squared, correct? Yeah, see?
Oh, yeah.
This is negative x squared, because negative x squared derivative is negative 2x. And then plus x, correct?
Yeah.
And then you do 1/2, you do -1. Plus, this guy antiderivative will be
X squared minus
x. And then you do this guy, 4 and 1/2. Okay?
Okay.
Yeah, and then you will look on the relationship of this thing is you plug in this guy into here, and then minus this guy into here, and then plus 4 into here, minus this guy into here with a parenthesis. So the calculation part is kind of complicated. Okay? That's what's going on. So it's not easy to get perfect antiderivative and also plug in with these 2 bonds. Okay? Next one. This is just a this is a circle. And here is from 0 to 5. Yesterday we have from -5 to 5, which is a it's a semicircle. But today it's only from 0 to 5. You figure out the radius is 5. You are doing a 1/4, so this is going to be a pi r squared. divided by 4. R squared is 25, so this is 1/4 times pi times 25. Now, number 6 and number 7 are all those same questions we did just now, but you only need to plug in the upper bound and lower bound. Go ahead, try number 6, number 7 by yourself on your paper and send me your work with the correct number plug-in. Go ahead, do by yourself. Good job, Maggie. Yeah, you get a number 6, number 7 all correct. That's perfect. Very fast. And your notes are very neat. Who else finished number 6, number 7? Send me your work, please. Good job, Felix. Very good. Super fast. Helen, you have some. Helen, you need to use the 25 plugin minus the 9 plugin. That's why you shouldn't have the negative in front, Helen. Helen, you need to use the upper bound to minus the lower bound. Helen, you did correct, but at the last step, you should put 25 at the front, 9 at the end. Okay, Helen?
Okay, because I wasn't sure if it was upper to lower or smaller to bigger.
From the upper to lower. Yeah, this guy minus this guy. Okay. Now I'm going to, let's do something more complicated. The next several example I'm going to show you guys is this guy here. Maggie, let's do this number 11, okay?
Okay.
So when you see this thing, so students, if you see question, look, when you see this, you will know, oh, I will make u as sine x. In that way, my du is cosine x dx. So Maggie, do you see this guy? So that you will know who is your u.
U is equal to tangent x.
Yes, u is tangent x, because if we make u equals to tangent x, then du is equals to
Secant squared x times dx.
good. So this part is du, okay? And then
Yeah.
you will see tangent x becomes u, so this is u to the power 1/2. And then you have du, correct?
Yeah.
And then x, when x equals to 0, u is going to be, tangent 0 will be 0. When x equals to pi over 4, u
U
will
is
be
equal to 1.
1. Tangent to pi over 4 is 1. So you put 0 here, you put 1 here. Equals, to this guy, antiderivative will be,
That'd be u to the power of 3/2 times 2/3.
so we have the u to the power of 1/2 plus 1, which is 3 over 2. And then we do this guy reciprocal, so 2 over 3. And then we will do this bar, we will put 1 on top, 0 on the bottom. So we will do 2 over 3 times 1 to the power of 3 over 2 is still 1, minus 0.
Yeah.
So this is 2 over 3. Okay? That makes
Okay.
sense, right? Yeah, that's what's going on. Now, number 12. Kyle, let's see this number 12.
Okay.
When you see this, look, no rush to randomly pick a u and then spend a long time writing down and figuring out it's not working. Do some observation first. Think about this. Who is this guy?
Well, isn't that 1?
Hey, hold on. Whose derivative is secant? Don't worry about 2x now.
Sure.
Whose derivative is tangent times secant? Whose
Isn't that-
derivative?
Isn't that secant?
Yeah, secant. Okay?
Yeah.
Secant u derivative is secant u times tangent u. Correct?
Yeah.
So that means here, look. So we will see, we will call this guy here, we will do a 1/2. And we will do secant 2x. And then tangent 2x. And then d of 2x. Okay?
Sure.
Are you okay
Well-
for here? Yeah, d of 2x means 2 times dx. So that 2 and this 1/2 will cancel. Okay?
Yeah.
And then this guy. This guy is exactly the derivative of secant 2x. That makes sense?
Yeah. So 1/2 times secant 2x.
Yeah. So if we make our u, we say
U is 2x.
this guy, that means the derivative. So I can call my u. I'm not going to call this thing. I'm going to call my u as 2x. Okay? U as my 2x. That means I have 1/2. And this is secant u. This is tangent u. And this is du. And if this x is from 0 to pi over 6, so u is going to from 0 to pi over 3.
Yeah.
Okay?
Sure.
And then this guy becomes 2. I'm going to call another guy. We haven't used the y yet. Yeah? So we can see our y is going to be secant u. Correct?
Yeah.
So that means the dy over du is secant u times tangent u. So far, so good?
Sure.
So that means secant u tangent u times du is d of y. Correct?
yeah.
Yeah? That is saying 1/2. And then this is whole thing is my dy. And now my y, when u is 0, y will be secant 0. Secant 0 is 1 over cosine 0. Cosine 0 is 1, so secant 0 is 1. Correct?
Yes.
When u is pi over 3, when u is pi over 3, secant y equals to secant pi over 3. Secant pi over 3, which is 1 over cosine pi over 3, which is 2. Correct?
Yeah.
So that means you will
Yeah.
have,
1 to 2.
when u is 0, y is 1. When u is pi over 3, y is 2. So this is from 1 to 2. Okay? So this is 1/2. And then
So what's the derivative?
this guy, look, this guy and this guy is going to cancel each other. So the output is y. This is just y. From 2 to 1. So which is 1/2 of 2 minus 1, which is 1/2. Does this make sense?
Yeah.
That's what's
a-
going on. Anybody? If you say I'm still confused with number 12. Let's talk about this one more time. Who want to walk through with me for this number 12? Any other student? Anybody? Kevin, do you need help for this question?
I'm looking over it. Hold on.
Okay, so first, the dx, because everybody is 2x, so you write down everybody to be 2x. Because if you do d of 2x, d of 2x means you do 2 times dx, okay? Yeah, so 2 times dx, 2 and 1/2 canceled. So this is equivalent as this, correct, Kevin?
Yes, I see.
And then you make u as 2x, okay? You make u as 2x, so that this becomes secant u, this becomes tangent u, and this becomes du. So far, so good?
Yep.
Because u is 2x, when you have the 2x, your pi over 6 will be double also, which is pi over 3. Okay? And then this is secant u times tangent u, and then du. Right?
Yep.
And that guy is our secant u derivative. So if you call the y as secant u, if you call
dy.
your, look, y as secant u, so dy over du will be secant u times tangent u. And then secant u times tangent u times du is going to be equals to dy. Yeah? So this guy totally replaced as dy. You have still this integral symbol here. When your u is 0, when u is 0, secant 0 is 1 over cosine 0, which is 1. When u is pi over 3, u is secant pi over 3, which is 1 over cosine pi over 3, which is 2. Okay? So you have this lower bound as 1. When it's 0, it's corresponding to 1. When it's pi over 3, it's corresponding to 2. And you have 1/2 this thing. Remember, we have f of f inverse something is going to equals to this guy. The antiderivative and the derivative will cancel each other. So this is just y. Okay? And then you do this y, the upper bound, the lower bound is given. So you just plug in 1/2 2 minus 1. That is 1/2. That's it. Okay? Now look at this. For both decimal and TI-inspired, it can do the definite integral. So what do you put here? See this thing? Everybody, you can open you can do this in your calculator. If you have the TI-inspired available, get it. And you can choose using the menu in the calculator button. You will, in the calculator button, you do the menu, calculus, and you will do the integral. And you put the lower bound as 0, upper bound as pi over 6, and you type in that expression. So for example, I put here 0. Here as, go ahead and do it on your own calculator. Grab your calculator, type in this. You can do in decimal, no problem. You can also do it in your TI-inspire, both are fine. So you do secant 2x times tangent 2x. Yes, ta-da, 0.5. Pretty cool, right? Go ahead, do it in your calculator. Do this in your calculator, okay?
No, do we type it in the graph section?
In your calculator, you click menu, not graphing session, in the calculator sessions.
Okay.
In the calculator session, okay?
1/2.
Like the place you do plus minus multiplication in that place.
Yeah,
And then you do manual.
1/2.
You do manual, do calculus, you do integral. And then you can put the upper bound, lower bound, and the expression. Yeah?
Yeah.
Yeah.
I
Who
did.
got it? Kevin got it. Who else? Kyle, did you get it in your calculator? That's it. Ah, you may say, oh, that means during the test, this is easy. Everybody who has a T-Inspire can do this question. No, in the test, no calculator allowed. These are the places no calculator allowed, okay? Your teacher will not allow you to use calculator. All this part is by hand only. This is number 12. Now let's see number 13. See here. Felix, they show you this graph. They say, okay, this is 2 sine x plus sine 2x. And they want to do the integral between 0 and pi. You know, if it's addition, we are welcome to split into this into 2 pieces. Okay, 2 you can drag in front, and then you have here. Felix, how much is this? How do we do this?
Is it 2 cosine x?
And negative 2 cosine x, right? And then from 0 to pi, correct?
Yeah.
And then plus. Think about this very carefully.
Do we first use u to substitute 2x?
You can do this in one step without using USub. This is possible without using the USub. You can do it directly.
So would you just do negative cosine 2x?
Yeah. But if you leave this, see here on. So sometimes we want to get rid of USub. We want to think this directly. Well, if you want to do negative cosine 2x, I don't know what number you should put here. So I'm going to first, I don't do anything. Look at here. I suppose this guy antiderivative should be negative cosine 2x. But if I think this is correct, then I'm going to check if this guy satisfies this. Look at this. This guy derivative is negative copy down. Cosine derivative is negative sine. So far, so good. But it's 2x, so you have to times the 2. Do you agree, Felix? So here, this result has a 2, but here it doesn't have a 2. That means I'm going to have a 1/2. You got it?
Yeah.
Yeah?
Yeah.
So far, so good?
Yeah.
And then you put the pi here and the 0 here. Okay?
Yeah.
Now, this is the time for you to do this plug-in. Negative 2. And then cosine pi minus cosine 0. Correct?
Yeah.
And then minus 1/2 cosine 2x. And then you put pi and 0. Yes?
Yeah.
This is negative 2. Who is this?
Negative 2.
Negative 2. Excellent. and then minus 1/2 cosine 2 pi, right? Minus cosine 2 times 0 is 0, correct? Who is this?
0.
0. So the result is 4. You got it?
Yeah.
Listen, everyone, listen. My daughter already registered her class for UT Austin already. And she took the pictures of those kind of classroom. In college, when you take those foundation courses like calculus or physics C in college, one professor is going to teach 400 or 500 students in one class. That's called a lecture. Do you think now it's more easy for you to understand, or you wait for college to learn this thing? At that time, that professor can make 500 students understood the stuff. This is the best time for you to truly understand this question, so that in college, you don't need to spend the tuition fee. Those calculus class 1 year at least cost your parents $3,000 to $8,000. Okay? You think the professor can be so patient to explain to individual students for those 500 kids size? No way. Do it now. Understand this. This is a basic class. You don't need to spend that kind of tuition fee. Understand now, pass those college board tests, get rating 4 or 5. You will get this credit. And it also increases your chance to be accepted into good college and good program. That's how to do this. If you ending up, look, some people say, I forgot to put a whole first. If you're ending up to be a negative, you look at this. This is above the x-axis. It's positive. It shouldn't be negative. Okay? And then let's see here. You want to do this guy area. Now, the area under this, they have you a secant square x over 2. And they ask you from this to this. So this is your lower bound. This is your upper bound. And see this guy here. Now I would like students to not depending on the USub so much. In the previous time when we learned about pre-cal and algebra 2, when we have, say, e to the power of 2x, yeah, minus 5 times e to the power of x plus 6 equals 0. Yeah, you want to solve this. Not always you have to say, oh, u equals e to the power of x. So this is u minus 2, this is u minus 3 equals 0. So u is 2, u is 3. So e to the power of x is 2, e to the power of x equals 3. Too slow. That's going to be your, like, when you are like a baby, you try to walk by some facility. Now this is time for you to throw it away. You already understand the concept. You should be able to writing down this in one step immediately. Don't always depending on you. Same thing for here. You don't need to do the intermediate value. Think about this. Secant square is who? Secant square is tangent derivative. Tangent derivative is secant square. So look, this is time I would like you guys to be able to do this in a fast way. Maggie, let's do this guy together.
Yes.
Tangent x derivative is
the secant squared x.
secant squared x. So tangent x over 2 derivative will be
secant squared of x
over
divided by
over 2
2.
times
Yeah.
times who?
Times 1/2.
Yes, that's the chain rule. Tangent x over 2 derivative, the outlier is tangent, so you do the secant square outside. And x over 2 is not x, so you have to do one more step. That's 1/2. And then that guy is saying your d of tangent x over 2 over d of x is equals to secant square x over 2 times 1/2. This is the guy like your u, but I don't want to use u. I just want to call this guy the whole thing over here. Does this expression make sense to everyone? Is this thing okay for everyone? Maggie, does this guy make sense to you?
Yes.
This is the composite function. It has 2 layers. If you say, I still feel confused, so you say y equals to tangent x over 2, yeah? And then dy over dx, which is the y prime. So that means you are going to do the outlier derivative, which is secant square. And then you do the inner layer, which is x over 2 derivative, which is 1/2. So that guy is this. Okay?
Okay.
Makes sense? So that means d of tangent x over 2 equals to this thing times dx. Correct?
Yes.
D of tangent x over 2 equals to secant square x over 2 times 1/2 times dx. Okay? And then secant square x over 2 dx is equals to 2 times d of tangent x over 2. Okay?
Yep.
And then you will replace this thing by 2 and then pi over 2, 2 pi over 3 d of tangent x over 2, like that. That makes sense.
Yes.
Antiderivative, derivative, these two guys balance each other, it's gone. You copy down 2, you copy down tangent x over 2. You put this bar, you put 2 pi over 3, you put pi over 2. Okay?
Okay.
And then you do 2 times tangent. This guy divided by 2 will be
Pi over 3.
pi over 3. This guy over 2 will be
Pi over 4.
pi over 4. Pi over 3 is, tangent pi over 3 is
Pi
square
over
tangent 60 degree equals
square root of 3.
Tangent pi over 4?
1.
1. So this is 2 times square root 3 minus 2. That's it. Take your time writing down the notes. If you say, I still don't understand, I will walk through with you. Go ahead, please. Write down the notes. If you think this part is hard, you privately text me a message. You say, teacher, I think this part is too hard for me. Okay. See? Using the calculator, I type in this, and my result here by hand is 2 times square root 3 minus 2. By the calculator, I found out exactly. The guy here gave me the output. And because this guy is not so smart, it doesn't give me the radical version. So I double check. Exactly, this is 2 times square root 3 minus 2. That's it. If you say, I will sneak the calculator during the test so that I'm able to type in this. No, if you don't show any work, no points. You have to show your work so that teacher know you can calculate this truly by yourself. Right now we haven't done 3D. This is only the 2D. This is say, okay, this is the secant square x over 2. And then give me the area bounded by this part. And when we, in the future, when we keep learning calculus, the question will become, say, here, this is the area bounded by this, okay? And then I want to say this shaded area will be revolved over the x-axis, and then calculate this 3D volume. Some people say, easy, using the cone. No, this is not a cone. When you use this guy revolved over this, that is not a cone. You will have other questions say, you have this shape, but you will revolve with the y-axis. Then what is the volume formula? What is the volume formed by this shaded area revolved over the y-axis? Before we learn that thing, we need to make this part correct first. This will be the foundation to solve the 3D irregular volume. Okay. Now, the last part I want to show you guys is this thing. The slope field. I'm going to show you who is a general solution, who is a specific solution. So you guys have this thing just now. But the C is a constant value. It depends on initial value so that you can get your correct C value. See here. If x equals 0, y equals to 0. Look, Kyle, if this is 0, this part will be 6, correct?
Yeah.
If this is 0, this will be 0. If y is 0, so 0 equals to 6 plus c. So c is negative 6. Okay?
Hold on.
Yes?
What is this problem?
This is the previous worksheet, number 7.
Oh,
Yeah, we did 40 minutes ago. Correct? Yeah?
yeah.
Yeah. So when x is 0, y equals 0, you plug in, you solve your c equals to negative 6. If you make c equals 0, if c is 0, x will be 0, then y will be 6 plus this guy. Yeah? When this is constant 0, this is also 0. So y will be 6 times square root 1, which is 6.
Yeah.
Now take a picture, everybody. Take a picture of this. Screenshot this one. Screenshot this one. Everybody screenshot, right? Now I'm going to show you the slope field. Get your TRN spare ready. I'm going to show you guys. This guy here. Yes. Did y'all see my pi-square calculator?
Yeah.
Okay. Now I'm going to start over. I'm going to clean it, okay? I'm going to use this parts. I'm going to say here, action. Delete all. Yes, delete. Okay. Now, clean your calculator. Go to the menu button. Go to the graph part. Click the menu. Click number 3. Not function, not relation, not equation, not conic, not parametric, not polar, not scatter plot, not sequence. This is differential equation right here. Everybody see the differential equation? And then with you, the guy here, did you see the prime here? Did you see the prime on the shoulder, right? This is already the prime. So what you need to do? You will do a fraction. You do that fraction. You do 9x squared over square root 1 plus x to the power of 3 plus 5x. Everybody finish this part?
Yep.
Enter. Enter.
Whoa.
Whoa.
A lot of lines.
Why does it look like this?
Do we have anybody here started physics C? Do we have anybody?
Oh wait, yeah, this looks like the magnetic field.
Yeah,
one.
exactly.
Hope you're not in physics C.
Yeah, exactly. Yeah, this is a magnetic field. Okay. And look, hold on. The story is not ending yet. So you see here, you can arrow. So for here, sometimes it's showing you the y2 prime. You will do the arrow button to scroll down, scroll up. Okay. If you have several different slope field, you can use arrow down, arrow up to go back. Okay. Now here, one more magic. One more magic. The solution. So Kevin, the solution here is the slope field is a general solution because we haven't give the initial condition. Now, look at your screen capture. The screen capture just now you have is x equals 0, y equals 0, correct? Yes.
Yes.
So go type in here 0, 0. That is your initial solution.
I need
Enter.
help. I get back to this.
You do the arrow button. Hold on. You use the arrow button.
It didn't do anything.
Then you click menu again. You click graphing again. You click a differential equation again.
Okay.
And then you use the arrow button. You get the y. Yeah. So you might wonder who is the pink. So you have those kind of slope field, but it's a magnetic field. You don't really know where the particle is moving on this field unless you give an initial value. You give initial point as 0, 0, and then you will have this. And then look at your graph just now, your screen capture. Now I'm going to show, go here, go here. I'm going to do menu. I'm going to enter a function. F1x, x equals 0, y equals 0, c is -6. So the y equals, the solution we have just now is 6 times square root. There. 1 plus x to the power 3. Ta-da! Move this out of the radical. Plus 5 over 2. I don't like to do this. I do 2.5 times x. And when I do x equals 0, y equals 0, my c is -6, so I do -6. Enter. Ha! Did you
Huh?
see? Yeah?
Oh, it matches.
Yeah. Okay? Does that make sense now?
Wait, isn't
Yes.
it supposed to be 2.5x squared?
Oh, yes, I have a typo here. Good
Sort of.
catching. Good catching. Let me fix here. See, it's showing
Ah.
F2. I do this guy square. Square. Okay, now it's a perfect matching. Okay? Did you all see? That's a beautiful run, okay? So in the future, when you learn those physics stuff, you will understand, oh, now I understand how to do this complicated stuff by calculus to get the analytical solution. And also, I can do this in the calculator. The general solution is the slope field. The specific solution is this. Well, if we do one more practice here, look at your screenshot. We have another condition. When x equals 0, if we put c is 0, y equals 6. So let's go ahead. Let's change. Do here, do differential equation, scroll up. The initial condition, I don't want to use 0, 0. I want to use 0, 6. When my c is 0, when my y is 6. So I change this guy to be 0, 6. Enter. You see? This time, because the initial position is changed, so the line is the pink one. That means we should do the manual here, and then we should change our F1 here, because when x equals 0, y equals 0, no, x equals 0, c is 0, y is 6. So initial condition here, then the c is 0. You move, see, ta-da, it's a perfect matching now. Does everybody get this perfect matching? Okay, based on your different initial condition, you will have different specific paths on this general slope field. That's what's going on. Okay, yeah. If you want to learn physics C, you have to learn the calculus first before you can learn physics C. All right, that's for today's class. Tomorrow will be our last class, and we will also have the boba tea party on Sunday afternoon. All right, I'm excited to see everyone. Please bring a second use book. If you cannot find a book, you can let me know. I can bring one book for you.
When is it?
Sunday afternoon. Your mom said you can go.
Yeah.
Okay. All right. See you tomorrow. Bye-bye.
Thank you.
Thank you.
Bye-bye.
Bye.
Yeah.